Hello, everybody. Good morning, good afternoon, good evening to every, depending on the place where you are connecting from. And welcome to a new edition of our Safe Dev Talks. Okay, in this case, regarding the software composition analysis and how we become the pain points into security gains, taking benefit of new capabilities, new challenges, new scenarios. So, thank you, everybody. For this session today, we count with Michael Wojcinski, that is a visionary leader in the application security area. Drove a lot of organizations to rethink their approach to this area in the application security, and has supported a lot of these new organizations. He has supported and empowered a lot of teams to adopt this forward thinking solution regarding software composition analysis. And for sure, he's going to bring us a lot of fresh perspective and ideas and approaches to this software composition analysis. Welcome, Michael, and
Hello.
thank you for being here. If you want to add anything from your side, also feel free to talk and
Yeah. Well,
to add any
hello
statement.
everyone. Hello everyone. I'm Michael, and I'm really excited to be here with you today. Yes, like presented before. Yes, I have spent years working with organizations on their journey to build secure, resilient software and tackling challenges that sometimes feel complex. And my role here today isn't just to talk about the tech side of things. It's actually more about simplifying and strategizing. It's actually more about helping teams to focus on what really matters without getting lost in all this noise.
Thank you very much. And we count also with Luis Rodriguez. This is the CTO of Sayeni. That is a solution for a lot of security topics across all this software development life cycle, and in particular for the composition and part and the integration of third-party components. Welcome, and thank you, Luis, also for being here.
Hi to everyone. It's a pleasure to chat with Michael today.
So let's start. For example, the first point is software composition analysis is like a traditional tool, but we are facing a lot of new situations, new challenges, new scenarios, okay, regarding or from the security point of view. For sure, the third-party components are something that are mandatory. Nobody can build software without using them, so it's a critical and fundamental part of the software development. In this sense, how do you see the software composition analysis currently, and what do you think that are the the latest challenges or the new challenges that we are facing in this area? I don't know. Start as you prefer. I don't know. Michael, for example.
Yeah. Okay. Well, let's start by defining the software composition analysis. Well, in simple terms. So how I usually start is by imagine that you are building a massive Lego castle, right? And you are using different pieces from different sets. Some of them are new, some of them are old, some of them are borrowed, and some of them are actually broken. So now, if some of those Lego pieces are broken or they do not fit well, this could actually make a whole structure unstable. So this is when the SEA came in, as SEA was there to actually help keep you track of all those Lego bricks, and actually to ensure that they are safe to use and they are actually compliant with the rules. So the same thing was here with the traditional SEA tools. So they actually worked more like checking all the Lego pieces after you have already built the castle. So this means that you were getting information a bit too late, and you were finding out about those broken risky pieces a bit too late. So now, in order to address those issues, you must either take apart or even rebuild some sections of your castle, right? So and also at the same time, as the software development became faster and actually more continuous than anything else, these tools just basically they just couldn't keep up. So in that case, actually what started happening, SCA started flagging almost every single Lego piece as risky. So even though there was no problem, there was no actual problem with that brick. So then automatically teams started spending too much time investigating issues that weren't even a real threat. So here the major issue is actually that those tools started generating just too much noise. And from this perspective, sometimes traditional SCA tools, they are being seen as that they are just reporting broken pieces, resulting in the teams just being flooded with more reports. And as a result, teams usually just don't have a clear direction on what to prioritize, basically.
Thank you very much, Michael.
Okay. First things first, the definition of SCA. SCA is a software composition analysis, which means many things for depending on the people who you talk to. Now is a part of the application security. Okay, the main focus of traditional SCA is vulnerability management. Vulnerabilities in the third-party components, in open source and third-party components. And also you have other features like licensing, checking if your use of the software is compliant with the licenses declared for the different components, and also obsolescence. That means that if you are using the very old or legacy components, these features are a mix of security, application security, and other regulatory or compliance features. For me, traditional SCA is a noise generator. Michael mentioned this. There is a lot of findings in the traditional SCA tool, traditional SCA approach. You have to manage a lot of vulnerabilities. Probably you are not under the risk that the tools says that you are, and you have to prioritize. You have to decide which of these vulnerabilities are real vulnerabilities, are affecting you in fact, and you have to manage all the changes you have to do on your legacy applications, taking into account a lot of potential risks that you don't know if they are real. So for me, traditional SCA is a source of noise in short terms.
I think
The point is what we do to fix that problem. This is what I hope we will talk later.
Yeah, I think, for example, Michael also mentioned that there is not a clear direction to prioritize the thing. So at the end, you have to solve everything. That is impossible because it should be infinite effort and time to solve everything. So at the end, these tools are not used and are rejected by the developers. And I am assuming that they are even putting more barriers to the development workflow, and so it's easy to adopt also in the organization because of this noise. Very interesting, very much. We have you have mentioned the noise, the prioritization as challenges, but I think there are also new challenges for third-party components. For example, I don't know, we have to put them in the organization. Probably we have silos of information that would be good to have everything integrated to do a smart decision, and this kind of the smart decision to prioritize and to decide what to solve with the information regarding context, impact in the business, and other capabilities will be great. So other part is the silos. For example, what about the malware that is taking the third-party components are being used to inject malware because it's the easy way to introduce malicious code in the application, because we have a lot of new packages. We are skipping the analysis from the software composition analysis. How do you see that it's also a new challenge for this kind of tools?
Mm.
Luis, in your case, for example.
Yeah, traditional SEA focus on vulnerabilities, known vulnerabilities. That means mishaps in the mishaps no, mistakes in the third-party components, not intentional, that open the door for attackers to enter to produce some misbehavior on the application code, but they are not intentional. The problem with malware is the supply chain attacks. When someone is able to inject malicious behavior in a third-party popular component, he uses that component to deliver the malware to 1,000 or hundreds of thousands of affected parties. This is which is named the software supply chain attack. The problem with traditional SEA is that it's not malware focused. Its focus is only vulnerabilities. So they don't have this idea. The new approach should take into account both risks, because you have vulnerabilities, of course, but you also have malicious code injected intentionally. And the problem with traditional SEA is that you know that you have a potential malware component when it was known that when it was removed from the package manager, from the registries of the package managers, which is too late because you probably were affected by the malicious component. So one very important trend for modern SEA is to take into account also the malware.
Thank you very much, Luis. Michael, I don't know if you want to add something in this line regarding known vulnerability or known risk for this kind of tools, or for example, from your perspective in the application security part, how do you integrate protection, or how do you consider this removing silos or other things that could be a barrier for adoption, for example, in the organizations?
Okay. Well, first of all, I already noticed that, yes, you have mentioned multiple types of vulnerabilities, and so did Luis. So, apologies. Yes, I agree that actually having a long list of just vulnerabilities without the context, it's pretty much useless, and it usually leads the organizations to start wasting time on chasing the wrong issues, basically like chasing your own tail. So, apologies. So here I could actually give an example. So if we refer back to the if we refer back to the massive Lego castle, and then that your tool keeps telling you that almost every single piece is broken, so it just keeps reporting vulnerabilities because vulnerabilities are there, right? That they are just there, and it still keeps reporting even though most of those bricks are completely fine. So then you spend all your time swapping out good pieces, and while the critical ones, like the one broken piece, is hidden somewhere in the structure and just goes unnoticed. So this is like fixing a harmless brick that is like already at the top of the castle, while the critical piece is found somewhere in the foundation, and it could actually cause the whole thing to collapse, regardless of what is it called. If it's called malware, if it's called, I don't know, a bad script or something else, basically, yeah. So this is exactly what happens when teams start chasing false positives from actual the traditional SEA tools, and like Luis mentioned, that at some point people can be just overwhelmed because there is a huge amount of those vulnerabilities and people just don't know where to start. So what I also have noticed is that I saw as a result that teams were getting something called patch paralysis. So it's that the teams, they didn't know even when or even how to start fixing those vulnerabilities, and this was causing even more delays, and those things were just left unpatched like a ticking time bomb. So actually, in this case, there are some policies and prioritizations. I believe that those things actually would be the key to reduce this whole paralysis, and it would actually allow people to act more on the most critical issues first. Yeah. So with this approach, I believe that actually having clear policies would be able to actually help teams to prioritize and act quickly. And actually silences, I would rather address them in a slightly different context. So from this perspective, there are also some good news that actually some modern SEA tools, they are actually now able to give you the context, give you reachability, and also they're able actually to help you to focus on the pieces that actually matter. So I'll just summarize this, that organizations, based on what I have seen, that the organizations are basically wasting most of the time on non-issues, while they are still leaving the real risks completely unmanaged. Yeah, so this is, yes, like Louis said, this is no longer just about having a lengthy list of vulnerabilities. This is actually more about knowing what to focus on and what actually matters at this time.
When you mean, Michael, when you talk context, what kind of context you would consider to prioritize the vulnerability? Is context from a technical point of view regarding this concept you mentioned regarding reachability, exploitability, scope, or any other regarding the organization, for example, the impact in the business, the area in the organization where it's the information. What's your view on this context? What would be the ideal context for criticization of these vulnerabilities? I don't know if I explain my question. Example, I don't know. What kind of information or list do you consider that would be great to make this prioritization based on something transversal across all the organization?
There are many entities there. The problem is that nobody knows what they mean. We speak about reachability, we speak about exploitability, we speak a lot of entities that nobody knows what it means. I think that the context is the most important thing to understand if you have to do anything with a reported vulnerability. I have a CVE, and okay, I have this third-party component that I'm using in this and this and this project, and how should I do to fix that CVE? That's the issue. So you have a 100 or 1,000 of CVEs, and you have to fix all of them. The context is, first, is this real? Is affecting me in fact? Second, is this software project do I need to fix it because maybe it's a legacy internal software and it's not exposed to internet, and the reachability is not effective because it's not on the internet. All this is part of the context. Also, you have to know if what means fixing that vulnerability, because the most traditional, from a technical point of view, fixed procedure is to update the version, to put a version bump, to update to a new version that fixes the vulnerability. But this is not as simple as it seems, because you have to check if the fix will break your software. If it breaks your software, you are so and this is quite difficult. If you have 1,000 of vulnerabilities to fix and you have to perform a strict procedure for fixing each vulnerability, you have no time. And this is where context with combined with automation and a proper help with tools and with whatever could add the context needed to decide which vulnerabilities should be fixed and which is the best process to remediate them. And this is quite complex because the software is complex, and modern software with all the DevOps methods and so on, it's quite difficult to change with automation to make this effective. And effectiveness is the key.
Mm-hmm. Thank you very much, Luis. Michael, I don't know if you want to add anything? If not, I have more question because Luis, for example, has mentioned reachability, exploitability. I don't know if everybody is familiar with these concepts.
Yeah.
Because, for example, reachability, I think is more or less established in what is. But exploitability, there are different assumptions or different meanings for exploitability. I don't know, for example, reachability. What does it mean for you? You mentioned also automation, Luis. So just high-level question: what is reachability? What is exploitability? How relevant are they for the prioritization process in order to remove noise and to focus on the vulnerabilities or the risks that are actually affecting my software? And then can do this analysis automatically and can do apply also automation for remediation for lots of things. I don't know your thoughts on this part.
Okay, so yeah, like Luis already said, yeah, that identifying vulnerabilities is no longer enough, and through reachability, I'll refer back again to the example with the Lego castle. It's actually to know if that tiny piece of code is sitting there, is it like a landmine, or is it actually a piece of code that will never even see the daylight. Yeah, so this is actually more about knowing if there's this particular element, if it's actually posing an actual threat. Because, well, I think we can all agree that we are all fully aware that in some production systems we've got some vulnerabilities, and this is kind of okay as long as we've got some control over them. So in this case, I actually I would rather ask if how can we actually transform all this data into an actionable insight. So like already again, like Lewis mentioned about vulnerability. So let's say that you are actually having a library that is having a critical vulnerability. Yes, this information is very useful. You just end up with one number. It's super highly critical, but this is just it's just the criticality, and it's way too simplistic to actually do something about it, right? Because this is just a statement. This is just an empty statement that this is highly critical. But in order to fix this, we need more context to make smarter decisions. So here's actually where the game changes. Instead of treating every vulnerability the same way, like, yes, those are criticals and we need to fix all those criticals. What about if we start thinking, is this vulnerability an actual threat? So like I said before, is it just lurking in your code as a landmine, or is it just a harmless piece of code that's just unused, that would just sit there? So this is where reachability and exploitability, they come into play. So they actually give us more context on what to focus on. So this is actually far more than just fixing the code. This is actually more about making decisions to save time. This is actually about making decisions to save some resources. And in the end, it's actually about protecting your business from the real threats. So I just already mentioned by Luis, fixing a vulnerability is no longer something as simple as just bumping up the version. Because you have to actually figure out, will this fix break anything else? What will be the ripple effect of this? You have to think, if you are going to fix one issue, if accidentally you are not going to introduce 5 additional issues. So, and then on top of this, people usually also forget to think about when defining criticality, that people tend to forget about where those vulnerabilities actually live. Is it critical software? Is it external facing? Is it causing some maybe compliance issues? Are we going to be facing some regulatory penalties? Yeah. So it's not only purely from the code point of view. It's actually far more.
Your vision is more. It's a wider vision, taking into consideration not only the propagation path or the dynamic execution path, is to put more information regarding exposition to internet, protection mechanisms, serialization is a wider concept, the reachability, or actually to measure the risk or the probability of the risk or the attack. Interesting, very much.
I am the tool vendor here, and I have a different approach, obviously, because I have to put in the context in the tool in the system to help the customers to leverage that context. Exploitability, you mentioned exploitability. It looks interesting, quite interesting, because it's the likelihood of being exploited based on factors that take into account the point of view of the attackers. The availability of exploits and tools, the actual hacking activity in the wild, it looks nice. The problem is that nobody use this in effective way. You have there are two tools, two ready-made tools for that. The EPSS scoring system from FIRST, and the KEP from CISA, the most important vulnerabilities that are actually exploited in the wild, on the wild. The problem is that nobody uses this effectively. You have a number there, and what I do with that number. This is the problem. For me, it's a little disappointing to learn that nobody understands what to do with the exploitability scores. The other thing is the reachability. Reachability is to know if the actually vulnerable code is actually executed in my software. And we use most of the tools use a search of the code graph, the methods that are actually called from the application code in the customer to the affected code in the component that has the vulnerability. The problem is, first, you don't know which is the vulnerable code, because the reporting of the vulnerability doesn't list that information. You have to get which code is vulnerable. For example, looking at the differences between the vulnerable component version and the fixed version. Looking at the difference, you find which functions change between the affected version and the fix. And then you have to look if your code transitively is calling in the code graph, as you mentioned, Jesus, if you reach the vulnerable code. This is quite difficult to do for tools and for any tool that the customer could be done in place. So, but this is key. This is really key, because most of the software I use in third-party companies, I am not using all the functions of the code. I am using a small part. Using that small part, do I reach the vulnerable one? This is the question that we have to answer to the users.
Regarding exploitability, Luis, there are also different approaches or definitions regarding exploitability, right? More based on some models, or because exploitability, for example, is what Michael mentioned before. Something is exploitable if it's exposed to internet, if has some context in whatever, but there are also specific exploitability. I don't know, for example, the EPSS, that is probability score that represent
nobody understands.
Others.
Nobody understands. I'm including in the package what that means. I can read the papers. I can read the definition from FIRST, but I don't understand what that means for me. This is the problem.
Okay. And I think you started showing different visions. Michael, more a wider approach, combining a lot of different things. Reachability, for your point of view, Luis, is something quite specific. But I think what I understand is from your point of view, Luis, from the tool point of view, is I can calculate all these small pieces of the context step by step, and then I can put together. So it's like there is a way to automatically build this context that Michael recommends or would like to have to prioritize everything, more or less? Is this approach correct? Because we have mentioned the reachability, exploitability, exposed to internet, business value, the other topics regarding the business that Michael mentioned.
The service criticality, for example, if it's not the same critical element, most of the vulnerabilities, even not non-reachable, should be fixed on really critical because you don't know. But the problem with is that you have this is environment, and the tools don't have environment information. They have the base sensor score. The base score, the tool says you the CVSS score, which is based, not using the information from the environment because it doesn't know the environment, and you have to add that context, which is pretty important for prioritization.
Mm-hmm. Very good, very good. Thank you very much. Back in at the beginning, Michael, you mentioned at the beginning that it was a problem if we check all the pieces of the Lego after building the artifacts and this kind of thing. So is the ideal point is to move as much of the left to the left as possible. Okay. How can we do this, or how we are, or the organization is doing this approach? Moving or doing this analysis before or as soon as they can, or how is being the software composition analysis being integrated in the continuous integration, continuous delivery, how they use these insights they find in the analysis, these kind of things.
Okay, well, so well, in security, we've been using actually tools for years, yeah, and SE is just another type of tooling that emerged. Before this, we had SAS, we had DAST, we had IaaS, we had Raspen, and multiple other tools. And then we also started with the CA. So yeah, taking into consideration that we have to actually think which software is critical, which one is actually externally facing, which one is actually most important. So once you actually calculate all those factors, then you'll actually be more prepared for the emerging new trends. Yeah. So going back to the tools, because you asked in the development lifecycle. So if there's tools like SCA, you've got SAS, you've got DAST, but they usually operate in isolation. So while the shift left is important, it was actually a great idea. There's still a problem on that side, because those tools, again, they operate in isolation. They don't share the data, they usually don't communicate, and they ultimately just leave you with the bunch of data or just pieces of the puzzles that you need to put them back together to get a whole picture, because you are just working with vulnerabilities. We are working without any context. We are working with no actual business context. So this is actually one of the problems that's happening on the left. And so since, yes, shift left has made tremendous progress, but now we should actually be thinking more beyond it. Like, this is why we are actually focusing more on the shift right. This is why it's crucial, and well, there's actually no doubt about that. Mm-hmm. But security actually must be looking from also this perspective, because this is about the product delivery, right? So it doesn't only happen on the left side when the product is being built. It's actually what's happening to it at later stage.
Mm-hmm. Right. With your experience,
I agree with Michael. We are focusing always in security tools, in application security on shift left. Okay, detect problems early. This is okay, and I think that SCA is well integrated with the dev part of DevOps. The problem is Ops also, because the software at the end goes to production, goes to the deployed into the cloud, for example. And the problem with vulnerabilities is when they are exposed, when they are put into production in the Ops part of the DevOps binary. So you have the information has to flow also to the right, to the Ops part of the binary. So I think that this is not well done. There are some ideas on how to publish the list of real vulnerabilities that end in the end product. For example, for integrated in SBOM, in the SBOM that accompanies the end product, the artifact that gets deployed. For example, a container image with vulnerabilities. You have a different standards for publishing that vulnerability, so the end user knows which vulnerabilities are in there. That's the problem is which is the rate of adoption of these standards, which is not great right now. It's not. There is a thing that now that there is a trend to put more emphasis on the software vendor. Probably this will be a requirement for many organizations to provide an accurate information about which vulnerabilities are reachable in the end product. We will look at this trend more in the future.
Michael, do you have some vision regarding the adoption of SBOM and if it's actually used in the application security strategy or plan of the organization? For example, as Luis mentioned, that will be one of the potential approach for the ops side, for example.
No. Yes, but always it depends how this tool is being used, right? Because you can just buy the tool and then it's not being used properly. It's not even configured or it's not even running. So yes, while we are seeing a promising trend, so called promising actually, like software bill of materials or pipeline composition analysis, the reality is that just identifying vulnerabilities is actually no longer enough. It's actually what are you going to do with the outcomes, with the data, or actually with the information coming from those tools. So going back to the context is the king, because without this, we are just going to be blindly patching vulnerabilities, and you'll be actually hoping for the best, that nothing is going to happen. But then when you add the context, whether it's from SBOM, PCA, SCA, DAS, SAS, or any other integrated security tools, then you can actually combine this data together to allow you, that actually would allow you to make your decisions smarter and actually make them faster. So and I think that this is actually the direction that the whole industry is moving forward, to actually make those tools talk to each other and share the data and actually work on something that is actually more actionable than just spitting out, just raw data, just raw numbers, and then people are saying, oh, we've got 5,000 vulnerabilities. How many critical? 300. But what does it mean? Right? It's just a number. It doesn't mean anything. How do I know if this 300 is actually critical, even though they are considered to be critical? But so what? Yeah, you can actually have, oh yeah, it will be a bad example, but you can have some, I don't know, I know what's it called, like you can have some plutonium, right? But plutonium, yeah, this is highly radioactive, right? But if it's stored properly, if actual context of this is actually secure, then what's the problem having such thing at home? Or like mercury. We used to have mercuries at home in our thermometers, right? Yes, it's a great risk. It's actually critical, yeah, you can die. But it was properly packaged and there were proper instructions, and then people were actually told how to use it. So in that context, it was still critical, but it wasn't posing any direct threat. Yeah. So it will, yeah. So this was this kind of reachability.
Yeah, thank you very much. Great.
Yeah, one point. Obviously, the list of vulnerabilities is nothing, serves for nothing. The point is that you can use a policy approach. When you are going to consume, for example, a container image in a Kubernetes cluster, you can use, for example, a Kubernetes admission controller that is enforcing by policy which images should be loaded or not, or discarded. For example, if I have some critical vulnerabilities in that SBOM, then I reject, because I don't want critical vulnerabilities in my Kubernetes cluster. So this is one of the current ways of leveraging the information that comes in the vulnerability reports. So it's not you have to put something on the runtime system to enforce that no vulnerable components are actually running. But you need the proper context. You need that vulnerability should be real ones. Hence, reachability again.
Okay, great. Taking note of this point. Thank you very much. Just to move forward, we have mentioned a lot of challenges, context, how to achieve it, how we can automate to gather all of those details to build this context or not. So okay, a lot of difficult things to do, but what things or how we become these pain points in improvements in security? If we overcome these challenges and we put in place a solution, what are the benefits, the gains of solving these barriers? How organizations are achieving these improvements and these security gains? And you have some sample, or for example, Michael, you mentioned before converting raw data into insights to improve the strategy. You have some sample of this and how they impact in the security improvement of the organization of the application. Or
Okay, well, I actually see this as something positive, because well, for years we've actually relied on tools that generated mountains of data, right? Data that was it was just overwhelming, and engineering teams were just bombarded with emails and with information about the criticality and how many vulnerabilities you still have got this week. But today, this data is transformed into more actionable information, because this data isn't just coming from one tool only that is just telling you, yeah, this is wrong, without any additional context. But now with multiple tools actually being able to not to talk to each other, but to create actionable results and provide you with more structured information, this actually allows us to see clearly what needs to be done, or what actually needs our attention at the moment. So it's actually more about reducing the noise, and then at the same time gaining the focus, right? So let's be happy that we no longer have to look at thousands of those records. We are only interested in a small portion of them. Yeah. So this is why the noise combined with noise actually from the SCA, and again, I'm not saying that all the SCA is generating noise. No, it's just specific types of SCAs. But then there's this noise generated by the SCA, when it's actually combined with the context and prioritization, this actually shifts from being a distraction into something that you can turn into strategic advantage. Yeah, because this actually allows you to focus on what matters the most, and you can actually take a meaningful action that would actually improve the security. So those two things combined, they actually end up as basically embedding security and into the DNA of the system, right? Because again, this is no longer just about reacting to vulnerabilities. It's actually about using those insights to build security into the DNA. So it's just completely, it's just integrated and seamless, right? So with the right information at the right time, you can actually react faster, and then you can align security with the development, and again, yeah, just make it more seamless, part of the process, just to make it easier for the people to use it.
I think this is a good point. Yeah, I can focus the activity of the development and operations team. So focus on this. Don't invest
Offload them. Yeah.
waste time in other parts. So it's easier to integrate in the development workflow and these kind of things. Liz, do you think the automation or these automated capabilities can support us also in being more proactive? Michael also commented, let's try to be less reactive and to prevent the risk before they reach the production or the public.
Application security tools and approaches, the traditional approach generated a lot of noise, a lot of findings from tools that nobody cared about. And this gave rise to a new beast which is the ASPM, the Application Security Posture Management, which is a new approach that takes prioritization at first, as the first element. And this is integrating different findings from different scanners, different tools, and trying to get the context for prioritization and for proper remediation, helping, for example, to filter out all the noise and getting only the vulnerabilities that really matter, and providing the help with remediation, documentation, and not only documentation but also tools aimed at remediating the issues more easily than the traditional way, manual way, following a checklist of steps that should be done. This is the no automation. You have automation for helping with remediation, which is the real thing. I know that I have a problem, a security problem, but I have to fix it. Help me with fixing it. This is the key, and this is where all the industries is working on.
Is focusing. Yeah, is the automation and the documentation, as Michael also mentioned. What do you have to do to solve this? Okay, great. Well, I think we have more or less covered all the topics that we have considered.
Can I just add one more thing?
Sure. Ahead.
Yeah. So going back to SPM. So yes, tools like SPM they help us to focus on the critical risks, and yes, ASPM helps to reduce all the noise and give more holistic view. Yeah, but well, actually, there's no but this is actually exciting shift that we are no longer trying to fix everything. But instead of this, we are rather focusing on what's most likely to affect us in the reward environments. So the question is, because earlier there was a question, are we secure in development? But I would actually change it a bit and actually ask that if we are actually ready for the reality of the new deployment, because this is what the issue might be.
I have one question for Michael.
Yeah.
Do you think that the adoption of SCA and similar approaches are quite spread for most organizations, or we are in an intermediate state yet?
Okay.
Your experience, based on your experience.
Yes. So I'm not from Gartner, no. So I don't have any metrics, but it's what I've noticed so far is being adopted, but companies not fully realize how to make a proper usage of those tools, because again, this like you mentioned before, this brings more noise. So when you know that you are going to bring in a tool that will actually generate more noise, you have to actually plan ahead. What are you going to do with this noise? How are you going to react to this information, right? Because we can just be constantly fed with bad information or bad news. But the most important thing is actually being able to filter out from this noise things that actually matter and things that are real, that are not false positives, that are actually things that actually matter.
Yeah, I've seen some. I think that some regulations, for example, in Europe, in the EU, DORA and NIS2, are drivers for adoption. In many cases, the organizations don't move a finger until they are there is a regulation that you have to be compliant with, and this is a major driver for adoption of this kind of approaches to vulnerability management and so on.
Okay, thank you very much. I think there were some questions, but I think that we have answered them regarding the exploitability mechanisms and reachability. So I don't see any new questions. Anyway, if someone has any questions, you can contact us later by any means. So feel free to ask anything else. Just to finish, Michael, Luis, a few minutes, 3-5 minutes to let your thoughts, your takeaways, your recommendations to the audience. How would you summarize the most important regarding software composition analysis challenges and how to take benefit of them for the new scenarios?
Okay, who goes first? Luis, me?
Michael, start
You.
let's start with you.
Well, just to summarize this in one sentence, well, everything I had is really good. Those are amazing insights. I would actually focus here on no. Okay, so yes, you can watch all the news, you can read all the articles, and you can be constantly bombarded and pumped with the information about the threats, about the risks, about the criticals, and you can be just, for the whole time you can be just stressed and not knowing what's happening. But then at the same time, it's up to you actually to determine which threats and which risks are applicable to you. So I think this the most important message here is don't jump to the first information, to the first detail about some vulnerability. Don't jump straight away trying to fix it, because actually doing this might cause more harm than good. So always analyze findings and be always prepared to filter out all the noise. I think that, yeah, that's it.
Thank you very much.
I start with one key takeaway taken from Michael. He said that now you don't have to fix every single vulnerability. You have to fix only the real ones, the ones that matter. I think this is the best advice for everyone. I'm looking at we are looking at a straight evolution of SCA as a concept. We are looking at a more complex SCA, looking for context. Context is king. This is obvious, and all the tools, all the processes, all the teams will be focused on getting the context to do the right thing at the right time. Second, malicious components. I think that they are entering the scene, and they are commonplace in some ecosystems. So we will see improved support of malware components in SCA tools and processes. And I'm looking at the convergence of container scanning, component vulnerability scanning, cloud native application security, and they have to be better integrated. They are different things, and I think that they have to. The information should flow, because we are talking about application security, and we will see more. Hopefully, we will see more integration between tools, between teams, to get that ideal goal, which is have a more secure application. I think this is time will tell, but we will see more approaches for integration. Let's see.
Thank you very much, Luis. Thank you very much, Michael. Thank you to everybody who attended today to our session. I hope all of you take some ideas, some approaches, and some new things to apply in your day-to-day or to research for future application in your DevOps or DevSecOps workflow. And I hope all of you to see all of you in our next session in a few weeks. So thank you very much.
Thank you.
Until the next way. Thank you, Michael. Thank you, Luke.
Thanks so much.
Thank you.
Bye.
Bye.